This is Miss Charmaine. Just wanted to take a few minutes to just explain to you what you're doing this afternoon. So in class today, we went through this first warm-up, and we started with this pizza planning party. So what we're doing here now is let's take a look at those learning targets before we get started. So number one was I can explain the meaning of the term constraints. I can tell which quantities in a situation can vary and which ones cannot. I can use letters and numbers to write expressions representing the quantities in a situation. Okay, so there are three learning targets for today. So you're going to learn what that word, we already know what that word constraint means, so that one we'll be able to check off our list. We're going to be able to really look at this second one right here in this video we're talking about, so which ones can vary and which ones cannot. And I can use letters and numbers to write expressions representing the quantities. So we started this in class, we're finishing it today at home. So if we look at the pizza planning activity, so what your job was you took 10 minutes in class today to use this menu in this calculator to plan out a party that you are going to be having. So what you were doing, you were planning a party that you were going to be the pizza party that you're going to be having in class. So you're using the number of students that you have in class to and some generalizations about how many cheese should you buy, how many pepperoni should you buy, what's the different types of pizza that you should buy, and you were listing out that items that you were going to buy. So for example, I put some in here. The pizzas are going to cost $12.99, and how many are you going to buy? You're going to tell me that number by just saying what number is it going to be. And then the total cost for that pizza. You're going to talk about the number bought and the total cost of those items, depending on the different items that you're buying. So if you need to insert rows here, you can just click in any one of these rows, insert a row below, and it will add one for you. Okay? So then you're going to talk about how much it's going to cost per person, knowing that we have 19 people in class. So from there, we looked at slide number 9, which then you're taking that pizza party that you had here, and you were writing down one or more equations or expressions. I'm going to say or expressions. Okay, and those expressions are going to be the number of items that you buy as a variable for each different food item that you buy. So, for example, that shows the total, the cost C estimate was how the cost C estimate was calculated. Be sure to identify what each of these variables represent. So you're going to be creating you can do it one of two ways. You can create one big expression of adding up all of the things that you're buying, or you can do separate, like if you were here, you could also write it as $12.99 P is equal to like the cost of that first one. You could separate it as $6.99 C or M, where you're multiplying the price per item times the P number of items. So you're talking about pizza, so you're talking about the P number of pizzas that cost $12.99 each, and you could write it as one big equation where you're adding each of those terms together to find that total cost, or you can just write each one as its own sort of expression, being sure that you explain and you describe to me what are those variables that you're talking about here. From there, you're looking at these constraints. We talked about these constraints in class a little bit, but let's take a look at what these constraints are again. So the constraints are limitations on the possible values of a variable in a model, often expressed by an equation or an inequality, or by specifically stating the value that it can or can't be. So for example, the distance above the ground, d in meters, can be constrained by non-negative numbers. Meaning, when you're talking about the height of something, you're never going to talk about it in a negative height. Nothing's going to ever have negative height. So it can be expressed by using this inequality of d is always greater than or equal to the number 0. Another example would be like in that apples and oranges situation where we're talking about For example, the number of apples, A, and oranges, O, that you can buy can be constrained to be non-negative numbers expressed by O, it's greater than or equal to 0, A is greater than or equal to 0. Can't have negative apples that you're buying. So this piece, the constraints piece, is really talking about the context of the story. So what are these numbers that it cannot be based on the context of this story? Okay? Then we talked about models, which models are very simple. They're mathematical or statistical representations of a problem from science, technology, engineering, work, or everyday life used to solve problems and make decisions. So like there's like E equals MC squared, but like we're not using that in our everyday lives. One that we might be using, I mean, not in our everyday lives, but one that we really could use would be one if we're trying to find the volume of something. We would find that by multiplying length times width times height. It's just a model is just a sort of mathematical expression or equation that we use in our everyday lives or has like a real world context. So for number 12, we're talking about constraints in this situation that we're talking about now. So in this pizza party, okay? So you're looking at your expressions that you wrote when planning your pizza party earlier. You're going to choose an expression that uses one or more letter. And for each letter, you're going to determine which value would be reasonable. For instance, could there be a non-whole number? A non-whole number, a whole number, a great number greater than 50, a negative number exactly 2. What are some reasonable values here? So when we're talking about those pizzas that we order, so we're talking about P pizzas, right? And with those P pizzas, we're not gonna order more than 10 pizzas because we only have 19 friends in class, and that would be sort of crazy to buy more than 10 pizzas. We're also not gonna buy a negative number. Okay, so that's one little piece of this variable. So if you're looking at this M, the number of mozzarella sticks, now you're going to think about it in two ways. First, you're not going to buy more than 20 orders of mozzarella sticks. I mean, I know that's kind of crazy to say like we could buy 20 orders of mozzarella sticks, but like we could, and we could all get our own order of mozzarella sticks because Mr. Main does not want to share. So we could say we're not buying any more than 20 orders of mozzarella sticks, or we're going to buy less than 20 orders of mozzarella sticks. And you're also not going to be able to buy a negative number. So we're also not buying a negative number. So what you need to do for this page right here is you need to maybe get rid of these guys here that I already put in here, add a few rows if you need to, and identify all of your variables and those reasonable values that you can identify for each of those variables in your story, okay? So then we're talking about constraints again, and this time you're actually going to be writing some statements, some inequalities or expressions for these constraints, okay? So when we're talking about this term, that means it's a segment of your equation that you wrote above. So one of the terms or pieces of it was this 1299p, okay? So we can write the constraints as inequalities. That's how we're mostly going to be writing constraints, is as inequalities. So we can say P, because when we talked about our reasonable values before, we said that P is going to be less than or equal to 14. We're not buying more than 14 pizzas. And when I say 14, I really mean 10, because that was the number we talked about before. Then we also have to write this constraint of P is less than or equal to 0. This can also be rewritten as 0 is less than or equal to P, which is less than or equal to 10. Okay, so this would be like a compound inequality. So you can do that you can make it or equal to by highlighting that symbol that you wrote in there and underlining it, simply underlining it. and then less than or equal to. So this would be like a compound inequality, like you probably don't have much experience with that. These are two separate inequalities. Same thing here with this guy for the Motzies, except your compound inequality would look like this guy here, except without this 10, it would be a 20, because 0 is less than or equal to p, which is less than or equal to 20. So that means the number of Motzies that you can buy, that you're going to buy, is going to fall between 0 and 20. You're also not going to buy a decimal order of your of this. So we're going to also say whole numbers. Only. Whole numbers only. Same thing for these Motzies. Your whole number only. Missed your brain. Okay, there we go. Last piece we're going to look at for this is here. So we're looking at this pizza party. So now this is where you're answering some questions independently. Okay, so you are looking at, in planning a pizza party, what are some ways that we gather information? So how did you gather your information? Where did you get the prices from? What were some assumptions that you made when you were going and you were making these and filling this in? What were some assumptions that you made? For example, we're not going to order more than, or people aren't going to eat more than 2 slices each. A lot of people like cheese, so we're going to buy a majority of cheese. People love buffalo wings, so we're going to get 5 orders of them. What assumptions did you make? Okay, suppose you gathered information differently. For instance, by asking every student the exact pizza toppings and number of slices they wanted. What would have been a reason? Would have been a regional approach? How would that have changed the estimated cost? So if you went to every single person and said, hey, what kind of pizza do you want? Hey, what kind of pizza do you want? How many pieces do you want? How many pieces do you want? Is that a reasonable approach to planning a pizza party? Think about it. Is that a reasonable approach? First of all. Then, how would that have changed your estimated cost? Probably would have, I don't know. So if you needed to pause, answer those questions, then let's look at number 15. So 15 is, suppose we had a different set of assumptions. For instance, assuming everyone loved pepperoni, Roni for life, and would like only 1 slice. How would that change the cost of your assumption or your estimate? Last piece is, I need you to come up with 3 situations that could have constraints. Okay, so for example, what might be some constraints in, say, planning a field trip or in organizing a community service event? Give me 3 possible situations, at least 1 constraint for each. Okay, so you're going to tell me a situation. I'm going to the store. I'm buying some apples and oranges. What are some constraints? Write them as inequalities like we did here. Okay, that's that. Pause yourself so you can work on that. Last piece is this exit slip, this cool down. Now you're planning an ice cream party. Ice cream party, woo, woo. Okay. You are writing an expression of the cost for this ice cream party. Okay. So you're going to state what each part of your, so you're going to write an expression. Then you're going to talk about your variables here. So parts or variables. I said this literally last time I filmed this, or variables. Okay, so you're going to look at your parts of your variables. You're going to put them down here, and you're going to tell me, what do they represent? V represents vanilla ice cream, the number of quarts of vanilla that I'm buying. C stands for the chocolate. S stands for sprinkles. Get me something. Give me some sort of expression and identify what each of those variables stands for. Last piece you need to do is, there's going to be a link down here that you're going to use for prices. Last piece is 17. You're going to choose a letter for your expressions. Describe the value that would be reasonable for each of those variables. So you're going to talk about all the variables that you chose here, inserting rows if you need them, and talking about what are some reasonable values and or constraints. So I would write them as constraints, Mr. Mean knows what she's trying to say, as inequalities for yourself. Okay, so I went through, you worked with me, maybe you just watched all the way through. All of this needs to be completed. reach out to me if you have any questions. I'll talk to you guys tomorrow. Bye, guys. Actually, wait. My code word for today. Mr. Rain totally forgot. My code word from today is going to be elephant. It's an elephant, I promise. Elephant. Send me an email with the word elephant. Bye, guys.